All right, now we're going to do multiple mass again, but this time I'm going to throw friction in the mix. It's not going to be a simple Atwood machine. It's going to be something like this. Now I could also put one of them on an incline, something like that, but the general philosophy on how to solve these stays the same. So let's go back to what we know we need to do when we have a multiple mass problem. We need a common frame. So when I say they have a common acceleration, I mean those accelerations need to have the same sign too. So once I choose the direction they're going to accelerate, I label it as my positive direction. The other thing they're going to have in common is there's going to be a third law pair. A force between them is going to be opposite and equal. In this case, I have a 2 kilogram object sitting on a surface with a coefficient of friction of 0.2, and this is a kinetic coefficient of friction. A string connects the two. The string goes over a frictionless massless pulley and connects to a 4 kilogram object. Later on we can do this with energy, but we are going to go ahead and do this with forces. So here we go. This is how we do it with forces. So the first thing we need is a free body diagram for each one to generate our equations, and then we solve our system of equations. So let's draw a free body diagram. So here I have, I'm just going to call it M2G, and I have tension. Here I have what I'll call M1G, tension. I have a normal force. The normal, again, is perpendicular to the surface. That's how I know its direction. And then I have the force of friction here. Maybe that's a little large for that. Make the tension a little bigger. All right, so from this, I'm going to generate my equation. So for the 2 kilogram, for M1, the sum of the forces in the x direction is going to be ma. It is accelerating in my x direction. The sum of the forces in the y direction is 0 for this one. Okay. So for M1 in the x direction, I have tension minus the force of friction equals ma, M1a to be specific. In the y direction, I have normal force minus M1g equals 0. For M2, I only have a y direction, so the sum of the forces in the y direction equals ma, because it is accelerating the y direction. Now down is my positive direction, so I'm going to have M2g minus tension equals M2a. And again, here's where you can do your check to make sure you set it up right. Check to make sure that third law pair is opposite. So one should have a negative, one should have a positive. At this point, I'm going to solve my system of equations to solve for the acceleration. All right, so I have friction, so substitute, substitute, substitute. So tension minus mu times the normal force equals M1a. Where do I find the normal force? Well, I find it over here in the y direction for this one. So normal force is equal to M1g. Plug it in, so I have tension minus mu M1g equals M1a. So at this point I can solve for either tension, substitute into the other one, and go from there. So here I'll solve for tension. So tension is going to be M2g minus M2a. So I'm going to move the tension over to this side. It becomes positive. Move the M2a over to this side. It becomes negative. Substitute this in. All right, so now I have M2g minus M2a minus mu M1g equals M1a. Notice, no common m. The m's are different, so it's not going to cancel out for me here. I do have to get all my a's on one side so that I can solve for it, so I'm going to have to move this over. And so I'm left with M2g minus mu M1g equals M1 plus M2, because both of them combine, so I'll factor out an A. Now an interesting thing here, if you can conceptualize this, go for it. So if I think about this as a system, as a group, it's going to have a total mass M1 plus M2. Okay. It's going to be being pulled in its positive direction by M2g, and it's going to be being pulled in its negative direction by the force of friction. And both masses are going to accelerate. So what happened to those tensions? Well, if one tension's pulling in the negative, one's in the positive, they canceled out. So conceptually speaking, you can kind of think about this as a single system and generate that equation rather than doing it this way. But this way is a little bit easier to start out with. And maybe once you get a little better, this is another option for you. So let's go ahead and plug in our numbers, see what we get for our acceleration. So M2 was my 4 kilograms, so I have 4g minus 0.2 times 2g, all divided by 4 plus 2 will give me my acceleration. My acceleration in this case is 1.96, so just under 2 meters per second squared. So again, when we do these multiple mass problems, create that acceleration that's in the positive direction, look for that third law pair to be opposite and equal, and solve your system of equations.